Yeah, good evening everyone. Good evening. Yeah, can we start now? I hope all the people came. Welcome to EPT RIC 2026 GATE CSE. I'm writing again. GATE CSE and DA RIC 2026. Welcome to EPT GATE CSE GATE DA RIC 2026. Yeah, I think we can start now. We can start. Right, we can start. Let's go to first problem. Let's go to the first problem. Yeah, can you see this? Can you see everyone? Everyone can see this problem. Yeah, see this problem and talk. There are n unsorted arrays A1 to AN. Assume that n is odd. It is the first problem. It is the first problem. There are n unsorted arrays A1 to AN. Assume that n is odd. Each of A1 to AN contains n distinct elements. There are no common elements between any two arrays. The worst case time complexity of computing the median of the elements, median of the medians of A1 to AN is. Yeah, can anyone try the answer for this? It is the first problem, right? Algorithm RIC, it is the first problem for GATE 2026. We are going to cover 300 problems. We are going to cover 300 tough problems. 300 tough problems. 300 tough problems we are going to cover. We are going to cover 300 tough problems. Yeah, can you try this one? There are n unsorted arrays A1 to AN. Assume that n is odd and each of A1 to AN contains n distinct elements. Remember A1 to AN, they are the array names. And the interesting thing is they are unsorted arrays. This is one array. This is one array. This is also one more array. This is also one more array. And important thing is unsorted arrays. They are unsorted arrays. They are unsorted arrays. We have n arrays where every array is unsorted, and assume that n is odd. Number of elements are odd. Each of A1 to AN contains n distinct elements, and there are no common elements between any two arrays. The worst case time complexity of computing the median of medians of A1 to AN is. Let's see how many people will give answer. Let's see how many people will give answer. Let's see how many people will give answer. Let me check. Everyone try this. Everyone try this. 300 problems we are going to cover. Every subject 300. Remember, every subject 300. Every subject 300. Like that, there are 13 subjects for CSE. Approximately 4,000 problems to 5,000, because for some subjects, right, 500 questions also there. So 4,000 to 5,000 questions. That is also tough questions we are going to cover. Very tough questions, right? And one more beautiful thing is, in the last year GATE examination, most of the questions came directly from RIC. Directly came from RIC. Most of the questions, either test series, right? EPT test series or EPT RIC. Most of the questions came from EPT RIC or test series are combined. So for CSE people, 4,000 to 5,000 problems we are going to cover. Tough problems we are going to cover. These problems contain some are PYQs. These problems contain some are PYQs. Some are tough problems. Anywhere, is it GATE or non-GATE, doesn't matter. All tough problems we kept here. All tough problems we kept here. This is for GATE CSE people. For GATE DA people, right, 300 questions for each subject, like that, approximately 10. So it's going to be 3,000 to 4,000 problems we are going to cover, which are tough problems. 3,000 to 4,000 tough problems we are going to cover for the GATE DA people. GATE DA people. GATE DA people, 3,000 to 4,000 questions. GATE CSE people, 4,000 to 5,000 questions we are going to cover. This is the first problem of today's class. This is the first problem of today's class. I don't know how many people will give answer for this. Can you check? Everyone try. Everyone try. What is the answer for this? Can you try? Everyone try. What is the answer for this? Someone is saying, sir, please start TOC also. Of course, after this I will start it. Someone is saying, please, please close the video so that we can see the question properly. Yeah, I will try this. I will try. I have the chance. I will try this. I have the chance. I will try. Is it okay? I think this is fine. This is perfect. I think this is perfect. I think this is perfect. Yeah, now it's okay. Now it's perfect. Now it is perfect. Everyone cooperate. Everyone cooperate. What is the answer of this problem? What is the answer of for this problem? Someone is saying n log n. Someone is saying n log n. Let's see how many people will give answer for this. Everyone try this. Everyone try. Everyone try. There are n unsorted arrays. Remember, n unsorted arrays. A1 to an. So let's try this one. This is one unsorted array. Careful. Yeah, I have to use another color, maybe red color. I am using red color or yellow color. See this one. This is one array. This is A1 array where this is the A1 array where n elements are there. This is the A2 array which contain. This is the A2 array which contain n elements. This is A3 array which contain n elements. This is A4 array which contain n elements. And so on, and so on, and so on. This is an array which contain n elements. Remember, we have n arrays. We have n arrays where every array contains n people. This problem is from one of the famous statement. This problem came right from one of the famous statement. What is that? Can you see this one? Everyone listen. Can you see this one? In unsorted array, it's a very, very important statement. In unsorted array, in unsorted array of n elements, in unsorted array of n elements, to find median, time complexity is n time. Please be careful. If anyone don't know, please careful. There is a one algorithm, median of 5 algorithm. There is a one algorithm, median of 5 algorithm. Using that algorithm, you can find out in the given array, right, median with order of n time. In the given array, in the given unsorted array, you can find out median using median of 5 algorithm with time complexity order of n. Now see what happened. Now see what happened. In this unsorted array, to find out the median, because of n people there, so n time. Here also to find out median, n people there, n time. Here also to find out median, n people there, n time. Here also n people there, n time. Here also n people there, n time. Remember. So n times n square time is over. We got median of every person. Now in this find out, in all these things, find out again median. Out of these n people to find out median, one more n time. So right, finding median of every person is n. Like that, n times you do n square. Now after getting the median, see here median 1 came, here median 2 came, here median 3 came, here median 4 came, and so on. Here median n came. Out of all these medians, find out the final median. right? Out of these n people, finding the median n time, n square plus n, which is going to be n square, which is going to be n square. So time complexity of this problem is big O of n square. Answer is option B. Answer is option B. Please be careful. Answer is option B. Answer is option B. So it cannot be the answer. It cannot be the answer. It cannot be the answer. Answer is option B. It's a very, very nice question. From this, the statement which you have to know is this statement you should know. This statement you should know. In unsorted array of n elements, to find out median, time complexity, order of n, you should know this one. Suppose in the sorted array to find out median, sorted array to find out median is 1. Sorted array to find out median is, sorted array to find out median is n. Sorted array 1, unsorted array n. This is the famous statement. So in the everywhere to find out median n time, n people 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 median n time. Like that n times you are doing n square, n times n square. N square time is over. I got a median of every unsorted array. Means I have now n medians. Out of them to find out one more median, one more n time. Right? This is median of medians. Median of medians. Median of medians, which is n. To find out individual median, n time. To find out individual median, n time. So n times n square. N times n square. Plus, after getting all the medians, again to find out the median, again, right, which will take order of n time. Finally, n square plus n, which is nothing but big O of n square. I hope everyone is clear. Let me know if anyone having any objection. Let me know if anyone having any objection. I have this doubt, sir. You ask me, I will help you. You ask me, I will help you. Let me know. Anyone having any doubt, please let me know. Anyone having any doubt, please let me know. Little doubt also there, let me know. Little doubt also. Little doubt also, please let me know. Someone is saying, why not D? Someone is saying, why not D? How you only say? Right? The answer is n square. Answer is n square. Omega means what? Left bigger. Omega means left bigger. Omega means left bigger. N square is bigger than n square log n. No. Remember, your answer is there on the left side. Your answer will be here. So your answer is n square. Answer is n square. Now see, n square is big O of n log n. No. N square is big O of n square. Yes. N square is big O of n. Wrong. N square is big O of n square log n. Wrong. Your answer is left side. Your answer is left side. You got answer as n square. N square is big O of n log n. No. N square is omega, right? Big O of n square. Yes. N square is big O of n, right? Which is going to be wrong. N square is big omega of n square log n. Wrong. Yeah. Perfect. Perfect. Thanks. Thanks everyone. Thanks everyone. Now let's move to next problem. It's a very, very important one. It is a very, very important one. Remember, it is a very, very important one. This question is going to be very, very important. This note is important. In unsorted array of n elements, to find out median, time complexity, order of n. In an unsorted array of n elements, to find out median, time complexity. This is a very, very important one. In the sorted array, order of 1, because middle person. In the unsorted array, median, order of n time, using median of 5 algorithm. Using median of 5 algorithm. Okay, I think you got it. I think you got it. Can you go to next problem? Can you go to next problem? Can you try this? What is the time complexity of this problem? What is the time complexity of this problem? I want answer from all of you. Please try everyone. Please try everyone. What is the time complexity of this problem? I'm going to cover 300 problems. I'm going to cover 300 problems. 300 problems I'm going to cover. Mostly questions will come from, right, RIC or test series. EPT, RIC or EPT test series. Most probably questions will come. Because I don't keep any dust in my classes. In my classes, nowhere I don't keep the dust. I don't keep the dust. Little dust also I don't want to keep because it belongs to students' time and all. Can you go ahead? For I is equal to 1, I power 5 less than or equal to n power 7, I plus plus. If I modulo 2 is equal to 0, j is equal to 1, j power 27 less than or equal to n power 99, j plus plus, x is equal to y plus z, return x. Can you say what is the time complexity of this program? Can you find out what is the time complexity of this program? GATE DA people same, right? Syntax will differ. GATE DA people same, syntax will differ. Syntax will differ. GATE DA people, just syntax will differ. Other than this, nothing. In the Python language, there is no mean. Right? For loop followed by colon will be there. If condition followed by colon will be there. Brackets are not there. Just you have to keep the gap. In the Python language, you have to keep the gap. Just syntax will differ, same thing. Both will be similar. Can you help me? What is the time complexity of this problem? It is going to be very dangerous problem. Let's see how many people will give. This is going to be very dangerous problem. Let's see how many people will give answer. Let's see how many people will give answer. Try what is the answer for this. Let's see how many people will give. Very less people will go. I am sure very less people. I am sure very less people will give. Very less people, not to, in my opinion, very less people will give. So for loop is how many times? And inner for loop is how many times? Please careful. Please careful. Inner loop is how many times? Outer loop is how many times? Very less people will go. I am very sure very less people will give. Very less. In my opinion, very less people will give answer. Some people, I think some people are crying also by seeing this problem. Some people are crying also. By seeing this problem, some people are crying also. Everyone try. Very less people will give answer. Very less people will give answer. No one having dare also. No one having dare also to touch this problem. No one having dare also to touch this problem. Can you touch this problem? No one having dare to touch this problem. I'm pretty sure in this. Anyone? I'm sure very less people will give answer. No one having dare also. Sir, it is very hard, sir. Bhaiya, you know. Pankaj Bhaiya, you know. मुझे मालूम पंकज भैया. पंकज भैया मुझे मालूम. Can anyone guess? Do you have any clue? Do you have any clue? Any clue? First of all, for loop is how many time? First of all, for loop is how many time? Outer for loop is how many time? Inner for loop is how many time? First find out outer for loop is how many time, inner for loop is how many time, lastly how many times we will see. We will see lastly how many time. Outer for loop is how many time, inner for loop is how many time, we will see. So Parthi is saying that n power 75 into 99 by 27. So he is from IIT Madras. This person is from IIT Madras. This person is from IIT Madras. Are Pardu, you written IIT Madras. Check properly, yaar. Dekho properly, yaar. Properly dekho. How can you give wrong answer? Check once again. Pardu, check once again. Dekho, yaar. Dekho. Anyone. Bro, any clue? Ayan, any clue? Pankaj, any clue? Anyone? Can anyone give the answer? Can anyone give the answer? Sir, just completed first year. Algo is new to me. Oh, you are from IIT Madras. IIT Madras BTech. IIT Madras BTech. Or you want to go to IIT Madras? Oh, BS. Okay, perfect. Now let's see this. Let's see everyone. Everyone see this. Everyone see. I'm giving the answer. Everyone can see. Can everyone see this? Everyone can see this. Can you see everyone? If you observe clearly, I loop is going on like this. See this one. I loop is going on. So I is equal to 1 going on. Right? So I is equal to 1. So 1 power 5 less than or equal to n power 7. True. I is equal to 2. So 2 power 5 less than or equal to n power 7. It is a continued. Can you help me? Some I value, right? Can you help me? I just want answer from all of you. I is keep on going. It's okay. Can you help me? Some I value, whole power 5 is less than or equal to n power 7. What can be that x? Some x value, x power 5 is less than or equal to n power 7. Can you help me? What is that x? Can anyone guess? So if you observe clearly, x power 5 less than or equal to n power 7. What x value? These two will be equal. I think if I write x as n power, let me write now, x as n power 7 by 5. If x has n power 7 by 5, means whole power 5 is less than or equal to n power 7. So a power m whole power n, a power mn, n power 7 by 5 into 5, n power 7 by 5 into 5 cancel 7 is less than or equal to n power 7. Remember. So I will keep on repeat. So n power 7 by 5 times. So first loop is n power 7 by 5 times. because next one fail. Next one fail. See, until here it will continue. Until here it will continue. Next one is fail because at this place both are equal. So further not equal. Further, right? Further left is greater. Until now, right greater, right greater, right greater. Lastly, both are equal. In the next line, left will be bigger. So for loop is gone. So first for loop is n power 7 by 5. First for loop is n power 7 by 5. Let's see the second loop. So afterwards we'll discuss about this. Afterwards we'll discuss about this. Let's see this for loop. Same story you can apply for. Same story you can apply for this also. Same story. What the answer? J value 1 going on, 2 going on, 3 going on, and so on, and so on. N power, listen, n power, everyone observe, n power. Make sure everyone give the answer to me. 99 by 27. Into 27, 22, 27, 27 cancel n power. So second loop will go these many times, right? This for loop will go n power 99 by 27. First outer for loop is n power 7 by 5. Inner loop is n power 99 by 27. Okay, I think you know inner one, outer one. So inner one is these many times. Sorry, outer one is these many times, inner one is these many times. Two inner loops. Normally you have to multiply. But remember, right, one work will be done m ways, another work will be done n ways. Both can be done at a time, m into n ways. N power 99 by 27. Actually like this. But you have to see some conditions also there. Some conditions also there you have to see. Let's see. I loop is n power 7 by 5. J loop is n power 99 by 27. Now observe here. Everyone observe. If no condition, nothing, this is the answer. If no condition, nothing, this is the answer. Assume no condition, this is the answer. In this problem, no condition at all, then this is the answer. N power 7 by 5 into n power 99 by 27. If no condition, this will be the answer. Everyone be careful, right? Fine. Because of condition, let's see what happened. I is equal to 1. Listen, I is equal to 1. It is a odd number. This condition is fail. So I is equal to 1. This loop will not execute. I is equal to 1. This loop will not execute. So I is equal to 2. Because of it is an even number, condition is true. Then this loop will execute. So each I value, J loop will not execute. Odd number, J loop will not execute. Even number, J loop will execute. That's okay. So I is equal to 1, you cannot go to the J loop. I is equal to 2, you can go to J loop. You can go to J loop. J loop will run. J loop will run n power 99 by 27. But do you believe or not? After the J loop is over, there is a return. I is equal to 2, you came inside. J loop is executed. J loop is executed. After J loop is over, return x. So return x means you are going out of this function. Return means what? In which function you are going out of that function. So what I mean to say is, I is equal to 1, you don't go to J loop. I is equal to 2, you will go to J loop. J loop will run n power 99 by 27. After n power 99 by 27, return x. So program will stop. So the time complexity of this program is simply order of n power 99 by 27. This is the time complexity, because only J loop will run. I loop will not run. I loop will run only 2 times. I is equal to 1, J loop will not execute. I is equal to 2, J loop will execute. How many times? These many times. These many times J loop will execute. Afterwards, return means program will stop. This is the time complexity. The time complexity of this program is finally n power 99 by 27. This is the time complexity of this program. No one will give answer. Trust me, this answer no one will give. This answer no one will give. Answer is n power 99 by 27. N power 99 by 27. Someone is saying x will be n square. Someone is saying x will be n square. How, yaar? If you write the n square, it will become n power 10. A power m whole power a power m whole power n a power mn. Check properly. This is the very dangerous problem. This is the very dangerous problem. Check once. Let me know if anyone is not clear. I is equal to 1. You don't go inside J loop. If no condition, answer is multiply both. Outer one also, inner one also, combinedly multiply. If no condition, inner, outer multiply. If condition is there, I is equal to 1, you cannot go inside. But I is equal to 2, you can go inside. I is equal to 1, you cannot go inside. But I is equal to 2, you can go inside. Yeah. For this saying, I just wrote n power 7 by 5 extra. Yeah. Means you didn't apply any condition. Parth Bhaiya, you didn't apply any condition. Simply you multiplied. But you are very close. Thank you so much. Thank you so much, Parth. Thank you so much. But you are very close. You almost cracked it. By seeing your answer, I almost cried. Array, one person came very close. By seeing your answer, I almost cried inside. Array, one person came very close to this. One person came very close to this. One person came very close to this. I felt like that. But anyhow, you done the small mistake. You done the small mistake. Can we move to next problem? Can we move to next problem? Can we move? Can we move to next problem? Hello, can we move to next problem? Ayan, can we move to next problem? Pankaj, can we move to next problem? Right, perfect then, perfect then. Right, let's move to next. So if anyone having any doubt, you can ask me. Sir, I have this doubt. Ask me, I will help you. Ask me little doubt also, I will help you. Right. Now just I want to say all of you, if anyone not taken EPT RIC course, if anyone not taken EPT RIC course, approximately 5,000 tough problems, 5,000 tough problems we are going to solve, plus test series, EPT test series. 5,000 problems we are going to solve. Tough problem, every subject tough problem we are going to solve. Every subject tough problem we are going to solve. 80% discount going on. 80% discount going on, you can utilize it. 80% discount going on, you can utilize it. You can use the code EPT 595 ARJ. You can apply this code. You will get the 80% discount. 80%. My purpose of EPT is helping students. That is the reason we are giving that much discount. EPT celebrating 5th anniversary. We are giving 80% discount. Right? Use this code, you will get the discount. Yeah, let's move to next problem. Similar problem. Can you try this? Similar problem, can you try this? Now, can you give at least answer now? Please give answer at least now. Please give answer at least now. At least now, please give answer. After every subject is over, RIC course also you see. One subject completed, see the RIC. One subject completed, see the RIC. Every subject completed, see the RIC. You will get a lot of advantage. You will get. Subject completed, right? Completed the RIC also. You will get a lot of advantage. Can you try at least what the answer for this? Try at least what the answer for this. Interesting thing is there is no return also. This is going to be easy. 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 Can you try this? Try this. What is the answer? Everyone, still some mistake is going on. Everyone, please try. There is a condition, even number, odd number. There is a condition. Yeah, let me say one important thing. So only for even number you go inside. Only for even number you go inside. Only for even number. Only for even number. You will go inside only for even number. So what happened is, so outer loop is going on n power 7 by 5. Inner loop is going on n power 99 by 27. So n power 7 by 5, n power 7 by 5 into n power 99 by 27. That is okay. That is okay. But remember, half times only will go. Maybe it's something like by 2. Half time only will go by 2. But asymptotically, it is going to be n power 7 by 5 into n power 99 by 27. Mathematically differ, but asymptotically same. Mathematically differ, but asymptotically same. Am I right? Am I right? Yes or no? Mathematically differ. So because only for even you will come inside. Only for even you will come inside. Yeah, true. Then you are correct. Mathematically differ, but asymptotically whatever you said is true. Asymptotically, this is the answer. Yes, exactly, you are correct. Yeah, I think many people are given answer for this. I'm very happy. Many people are given answer for this. Many people. I'm very happy. Many people are given answer. This is also one more important question. This is also one more important question. Can you read it? Can you read this problem? This is also one more important question. Can you read it? Everyone, can you read this problem? This is the next problem. This is also a tough problem. This is also a tough problem. Can you go ahead? The minimum number of comparisons needed to determine if an integer appears more than n by 2 times in sorted array of n elements or not. The minimum number of comparisons needed to determine if an integer appear more than n by 2 times in sorted array of n elements or not. Can you try this? It's a very, very interesting problem. The minimum number of comparisons needed to determine if an integer appear more than n by 2 times in sorted array of n elements or not. If I give array, if I give one sorted array, remember, if I give one sorted array, in that sorted array, if any element repeating more than half time, you have to return 1. If no element like that, you have to return -1. I'm repeating once again. In the given sorted array, if any element repeating more than half, you have to return that element. Otherwise, you have to return -1. To do this task, how many comparisons needed? To do this task, how many comparisons are needed? Please, can you go ahead? The minimum number of comparisons needed to determine if an integer appear more than n by 2 times in sorted array of n elements or not. It's a very, very tricky question. Very, very tricky question. Let's see how many people will give answer. Let's see how many people will give answer. Someone is saying, IN is saying log n. IN saying log n. IN saying log n. How so? How so? How it is? How it is? Can you help me how it is? So you can see the options. You can see the option and you can select. You can see the option and you can select. You can see the option and you can select. The minimum number of comparisons needed to determine if an integer appear more than n by 2 times in sorted array of n elements or not. Remember see, I am giving the hint also. Given array is sorted. Given array is sorted. Remember. And one more. If any element repeating more than half time, you have to return that element. If not repeating more than half, you have to return -1. To do that task, how many comparisons are needed? That is a given problem. So I'm going to help you. Can you see this? Can you see this one? Sorted array. Take one sorted array. 10, 20, 30, 40, 40, 40, 40. I think it's fine. Yeah. 1, 2, 3, 4, 5, 6, 7. Right? 6, 7. So if you observe clearly, carefully observe. I think if you want, I can give some more elements also. I think these are more than enough. If you observe clearly, this particular one contains 7 people. Right? Half of that, 7 by 2 is going to be, if you find the 7 people, half, 7 by 2, 3.5. So there is a one person more than 3.5 times repeating. There is a one person more than 3.5 times repeating. If you want, you can check. If you want, you can check. If you don't want fraction, you can go further also. If you don't want fraction, you can go further also. Let me try. 40, so 8. Yeah, if you don't want fraction, if you don't want any confusion, so I'm taking, see, one sorted array is there. This sorted array contains 8 people. 8 by 2 is 4. 8 by 2 is 4. One person repeating more than 4 times. Check. I think that person is right. That person is 40. So you have to identify, is there anyone repeating more than half time? You have to find out, is there anyone repeating more than half time? You have to find out, is there anyone repeating more than half time? So understand everyone, everyone try to understand. Everyone try to understand. Be careful, be careful. So in the given sorted array, if any element repeating more than half time, compulsory, if at all any element repeating more than half time, compulsory is the middle person. 8 by 2, 4. If you want, you can verify. In the given sorted array, if any person repeating more than half, he should be the middle person. He should be the middle person. Suppose he started from leftmost place, compulsory he will cross middle. If he start from rightmost place, compulsory he will cross the middle. So what I mean to say is, in the given sorted array, if any element repeating more than half time, he should be the middle person. So answer should be 40, but we have to verify, is he really repeating or not? I cannot simply return middle person. If at all in the given sorted array, any person repeating more than half, he should be the middle person. But I cannot give guarantee every middle person is having that behavior. Is it really having or not? We can check. If at all answer exists, it should be 40. So see the first step. See the algorithm. Algorithm I am writing. Find middle person. Find middle element. Mid element. Find mid element. And if at all any element repeating more than half in sorted array, then it should be middle. So find mid element, because I'm writing find mid element, because if at all any element repeating more than half in sorted array, then it should be middle person. So if at all, remember, if anyone repeating more than half, it should be middle, but every middle cannot be more than half. So I will give one example also. Every middle I cannot give guarantee. See, 10, 20, 30, 40, 50, 60, 70, 80. 1, 2, 3, 4, 5, 6, 7, 8. So I cannot say 8 by 2 is 4. I cannot say 40 is the one which is repeating more than half. Every middle I cannot give guarantee it is repeating more than half. If more than half times repeating, it should be middle person. If anyone repeating more than half, he should be middle person. Every middle cannot give guarantee it is repeating more than half. So find the middle element, because if at all any element repeating more than half in the sorted array, then it should be middle person. Okay, I computed. So find the middle. Yes, I computed. Now see the second step. Answer is, listen, I am not confirmed. If at all answer will be 40. Answer will be 40. Now see, I have to confirm. Let me verify. Second step is verify. Verify mid element repeating more than half or not. More than half times or not. Verify mid element repeating more than half times or not. Verify mid element repeating more than half time or not. Some people are asking, sir, how to verify? Using, because of sorted array, using binary search, you can do it. Using binary search, you can do it. Using binary search, you can do it. Some people are asking, sir, how, sir? I'm doing this. Very interesting, I'm doing. Can you see this one? Can you see this one? Using binary search, you can do. How? The next question is going to be how. How can you do this? Very simple. First step, everyone listen. Everyone listen. Everyone listen. X is equal to index of index of first occurrence of mid element. X is equal to index of first occurrence of mid element. So how you find out? Find it using binary search. X is equal to index of first occurrence of mid element. Find it using binary search. Using binary search, the answer will be, you know very well, you are checking for 40 only. Using binary search, find out first occurrence of 40. I think 4. So X is 4. In the similar way, Y is equal to index of last occurrence of mid element. Index of last occurrence of mid element. Find it using binary search. So that is Y. So which is going to be 8. This is 8. Then so X to Y, how many people are there? You know one formula there. Last one minus first one plus 1. So Y is 8, X is 4 plus 1. Which is going to be 8 minus 4, 4 plus 1, 5 people. So this is 5. This 5 is greater than 8 by 2. Yes, exactly correct. So answer is mid element. Answer is mid element. So return 40. So return 40. That's it. Verify mid element repeating more than half times or not using binary search. Right? So how you do this? Find the first occurrence of mid element index. Find the last occurrence of mid element index. Using binary search, you do it. After finding, so you know the first index, last index, you know. Last minus first plus 1, you do. You will get the total times, how many times it came? 5 times. Is 5 is greater than 8 by 4, means n by 2? Yes. So mid element is the answer. Return 40. Remember? Here you are applying binary search, which is log n. Here also you are applying binary search, which is log n. 2 times binary search you are doing. 2 times binary search. 2 times binary search. 1 time binary search log n. 2 times 2 log n. 2 times 2 log n, which is nothing but order of log n. So the answer of this problem is order of log n. So I given the very rough diagram. Find mid element, because if at all any element repeating more than half in sorted array, it should be middle person. So find out a mid one. Next one. Verify mid person repeating more than half times or not using binary search. How will you do it? Find the first occurrence of the right mid element index, which is X. Find the last occurrence of the mid element index, which is Y. But using binary search you do, because of it is a sorted array. So Y minus X plus 1, this is the way how to find out number of people from X to Y, which is more than n by 2. So this mid element is the answer. Return that person. So 2 times you applied binary search. First occurrence finding, last occurrence finding, 2 log n, which is nothing but log n. It is an excellent problem. This problem is excellent problem. Someone is saying return end pointer. Can you see that? Karna saying Y minus X plus 1 is equal to 3. 8 minus 4 is 4 plus 1. 5. 5 na bhaiya? Shouldn't we also check first element and mid minus 1 equal or not? What is the need? So you are thinking that it is starting from left hand side. You are thinking that it will start from first place. Need not be. It will start from last place. Need not be. It can start anywhere. It can end anywhere. It can start anywhere. It can end anywhere. Fine. Sir, last element is always the leader. So take max is equal to an minus 1. And then max, right? What is saying? Leader. So next problem you are saying. Karna saying next problem answer. Karna saying next problem answer. Karna, what about the current problem? Current problem, yeah. So current problem is okay. Bro, current problem is okay. Is it perfect? Is it okay? This problem is okay. The minimum number of comparisons needed to determine if an entries appear more than 1 by 2 times in the sorted array of n elements are not. Okay, perfect. 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 Yeah. Now the question is going to be very interesting. Very interesting. What is the answer of this problem? Listen. What is the answer of this problem? What is the answer of this problem? If not sorted, to find out any person of this type, right? It's going to be very interesting one. That is going to be Morse voting algorithm. Morse voting algorithm. Morse voting algorithm means voting algorithm. In the voting algorithm also same. If anyone got more than half, he will be the winner. So almost like one scan is required. Almost one scan is required. Morse voting algorithm. Using Morse voting algorithm, you can do it. So at that time, order of n time. Morse voting algorithm is order of n time. So same problem, sorted array, log n time. Unsorted array, n time. Right? Sorted array, log n time. Sorted array, log n time. Unsorted array, n time. Unsorted array, n time. Using Morse algorithm. Morse voting algorithm. Remember this. The minimum number of comparisons needed to determine if an integer appears more than half in unsorted array, n time, using Morse voting algorithm. Sorted array, order of log n. Right? Perfect. Perfect. Now go to this problem. Go to this problem. Try what the answer for this. Try what the answer for this. Everyone try. Everyone. If some people see, some people don't try. Now they don't try. Some students, they don't try now. They don't try now. Last month they will cry. Last month they will cry, saying that, sir, lot of time is taking, sir. Reddy sir, lot of time is taking. What should I do, sir? Reddy sir, lot of time is taking. What should I do, sir? I'm repeating. I'm saying again. See, many people don't do now. Many people don't do practice now. Postpone. Last 1 month, 2 months they will start. Right? How many problems you can do? Last 1 month, 2 months, 13 subjects. 13 subjects are approximately 10 subjects. Last 1 month, 2 months, if you start, how many you can solve? Yeah, nothing. Those people who will try last 1 month, last 2 months, trust me, you don't get more than 50 marks. If you start practicing last 2 months, you don't get more than 50 marks. If you are starting from now onwards, now onwards you may get the 50, 60. If you keep on improving, right, lastly you will get the 80, 90 marks. Please start doing now. Please start doing now. My request to all the people, please start doing now. My request to all the people, please start doing now. If you don't do now, I think it's gone. If you don't do practice now, it is gone. If you don't do practice now, it is gone. Yeah, what is the answer of this problem? An element in an array A is called leader if it is a greater than all elements to the right of it in A. The best algorithm to find all leaders in an array. Can you give answer for this? Try everyone. Try everyone. Try. Try everyone. So Karna saying B option. Karna saying B option. Okay. Okay. Karna saying B option. Of course, there may be. See, an element in an array A is called a leader if it is greater than all elements to the right of it in A. If it is greater than all the elements which are there on the right hand side. The best algorithm to find all leaders, the best algorithm to find out all leaders in an array. The best algorithm to find out all leaders in an array. Everyone try, everyone try. Don't postpone, don't postpone. Everyone try, don't postpone. Yeah, so if anyone is troubling, I will give one example. You try this. This is a array. This is a array. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let me give some elements. 80, 15, 70, 60, 20, 20, so 90, 65, 35, 44, 29. Yeah, this is the one. Now, first of all, before going to give answer, first to identify yourself, who are the leaders here. First to find leaders. Who are leaders? Who are the leaders? Or what are the leaders? What are the leaders here? Find leaders. Find leaders. One, two, three, four, 5, 6, 7, 8, 9, 10. Find leaders. Find leaders. First find leaders. Forget about algorithm. Forget about algorithm. First find leaders. Forget about algorithm. First find the leaders. So if you observe clearly, what is the leader definition? Any person is said to be a leader if it is greater than all the people present on the right hand side. Right? All the elements present on the right hand side. So see this one. If you want to say he is a leader, he should be greater than all the people on the right hand side. So I think there is someone who is greater than him. So 80 is not a leader. So if you want to check if 15 is a leader, right, he should be greater than all the people on the right hand side. So I think no. What about 70? No. What about 60? No. What about 20? No. What about 90? Yes. What about 65? Yes. What about 35? No. What about 44? Yes. What about 29? Yes. Because more than 25, no one. So if you see the right hand side of the 29, no one is there. The right hand side of 21, no one there. So is a leader. So remember, last person anyhow leader. Last person anyhow leader. So in the array, how many leaders are there? I think in this array there are 4 leaders. 4 leaders are there in this array. In this array, 4 leaders are present. They are in this array, 4 leaders are there. They are 90, 65, 44, 29. In this array, there are 4 leaders, right? 90, 65, 44, 29. Right? 90, 65, 44, 29. There are 4 leaders in this array. Some people are asking, sir, how much time? So if you start from left hand side, listen, if you start from left hand side, for every person, all the people on the right hand side, you have to check. For every person, all the people on the right hand side, you have to check. For every person, n time, n time, n time, n time, n times n square. If you start from left hand side, answer is n times n. Answer is n times n, which is n square. If you start from left hand side, time complexity n square, because first one will be compared with all, second one will be compared all right side people. So time complexity n square if you start from left hand side. Let me start from right hand side. Very interesting. This problem is interesting if you start from right hand side. This problem is interesting if you start from right hand side. Start from right hand side. This problem is interesting. Start from right hand side. This problem is interesting. I'm starting. Very interesting answer. I'm starting. Everyone listen. Everyone listen. Everyone listen. So if you start from right hand side, you know very well, last person anyhow later. Last person anyhow later, first print it. Whoever last person, first print it. Not only that, maintain one person, max is equal to last person. Take one variable, local variable max, which is last person. Last person printed also. Take maximum, as of now maximum, from right hand side 29. I'm repeating once again. Take the last person and print it is a leader already. And store that person in the maximum, right? Which will say that maximum always contain. Till now on the right hand side, who is maximum? Till now on the right hand side, as of now, maximum 29. Now see what happened. So until now, no problem. Now see, go to the next one. Go to the next one. See this one. Ask the next person, is he more than the existing maximum? Is he more than the existing maximum? Yes, yes. If it is more than the existing maximum, then he will be a leader. Then update the maximum also. Always, whoever new person is coming, that person have to ask the maximum. Am I greater than you? If at all new person is greater than the maximum, he will be a leader. Right? Then you have to update also, print also, update also. If at all is not more, then is not a leader, skip it. Now see the answer. Next person 35 came and is asking maximum, right? Am I greater than you? No, then he is not a leader. Don't print it and don't update also. So 65 is asking, am I greater than you? Maximum, am I greater than you? Yes. Then you are a leader and print also. Print and update also. Next one, 90 is asking, am I greater than you maximum? Yes. Then you are a leader and update also and print also. Then 20 asking, am I greater than you? No. 60 asking, am I greater than you? No. 70 asking, am I greater than you? No. 15 asking, am I greater than you? No. 80 is asking, am I greater than you? No. So I think from right hand side, simply one scan. From right hand side, simply one scan. One scan means linear time. So order of n time. From right hand side, it is order of n time. From left hand side, from the left hand side, it is n square. From left hand side, it is n square. From right hand side, it is n. Right? This is the famous algorithm. This is the one of the famous algorithm. Take the last person itself is maximum and print him also. Then take one for loop and start comparing from right hand side. Every new person will ask the existing maxima, am I greater than you? Yes. Then print him and update max also. Am I greater than you? Yes. Print it and update also. Print it, update also. Continue, continue. Suppose at anywhere if we say, no, you are not greater than me, then don't update also, don't print also. Simply one scan. Simply one scan. So time complexity order of n, it is one of the nice problem. It is one of the nice problem. Answer is going to be second option. Someone is mentioned, answer is second option. Thank you. Bro, thank you. This is going to be very complex problem if you see from left hand side. Do from left hand side, it is a complex problem. Do from right hand side, it is a very easy problem. Do from right hand side, it is a very easy problem. Do from left side, it is going to be very complex problem. Let's see how many people are okay with this. Let's see how many people are okay with this. Rajavardhan saying, how are you, sir? Yeah, Rajavardhan, I am fine. How are you, Rajavardhan? Rajavardhan, I am fine. How are you? Yeah, perfect. Perfect. Yeah, so these many problems we done today. Today we done the very nice problems. Tomorrow we'll see the remaining problems. Tomorrow we'll see the remaining problems. Tomorrow we'll see the remaining problems. Right? Today we done approximately 6 or 7 very good problems we done. So many problems are there. So many problems are there. Tomorrow we are going to do all these problems. So many problems, so many good problems are available. And one more thing is, those people who want to prepare for 2026 GATE CSE if you want to prepare, or GATE DA if you want to prepare 2026, there is a, because of EPT anniversary, 80% discount available. 80% discount available. Please utilize. Use this code. You will get the 80% discount. You can go for full course. You can go for GATE CSE full course or GATE DA full course for 2026. You can go. And one more thing is rank improvement course also. You can go for GATE CSE, GATE DA. Right? So 80%. It is a maximum discount. Because of anniversary, it is a maximum discount. Please utilize. Please utilize. We are going to cover 5,000 problems. We are going to cover 5,000 difficult problem. Most of the questions will come directly from RIC or test series or class notes. I'm very sure I am saying to you. Most of the questions will come either from RIC or from test series or from class notes. Right? Yeah, someone is saying that PDF and all. Someone is saying PDF and all. Yeah, we may provide that. Right? Few problems, right? We may provide. Yeah, thanks everyone. See you in the next class. Thank you all. See you in the next class. Yeah, bye. Good night. Bye.